Good afternoon, ladies and gentlemen. Welcome back to another exciting episode of how to identify components in the engineering labs for electrical engineering at VUT. Today we're looking at transistors. We're using a multimeter to identify a transistor and the transistor legs, the fastest method. There are different methods in the textbook, and you are encouraged to measure and to play with your components. Two types of bodies of transistors exist: metal can and little plastic or silicon versions of transistors. If I zoom in a little bit, you should be able to see that that component has got a little bit of writing, and this one also. I swing it around, there is some writing there. So what does it mean? There's a model involved, and that model tells me what is this transistor all about. We get the information in something called a data sheet. The data sheet is, there's a copy of this specific model of transistors in your textbook, and you have to refer to it. One can use the internet to search for data sheets as well, especially if it's a new type of component that you're not familiar with. But if I now use a multimeter has got, or some of the models has got a little arrangement here which allows for NPN and PNP transistors to be identified. And the whole idea of that is, firstly, a very quick way and convenient way of identifying where is the emitter, the base and the collector. And then secondly, it tells me what is the internal gain, the HFE or the DC beta of that component. So if I take a transistor and I'm not sure as to what the arrangement of legs are, I make sure that my meter is here by HFE, which is an H parameter indicating the gain of the transistor. And if I plug it into PNP, nothing is happening. Why? Because we suspect that this transistor is a NPN transistor. And depending on how it is installed, eventually it will give you a reading. In this case, the reading gives me 246. Remember, beta doesn't have a unit, it is just a ratio of input current towards output current, the base current and the collector current. So if I now have it with my fingers, look at that, all of a sudden the value changes. So why is that happening? My fingers is much warmer than room temperature, and the gain in your transistor of that junction depends on the temperature or the environment that it is in. And the beauty of it, as it cools down, the gain goes less, and if you heat it up slightly, the gain will increase. So that's an interesting thing about amplifiers, because the longer you play with your amplifier, the longer you listen to your music, the more gain you have. And eventually, if you go over the gain, you can actually destroy your amplifier because it will overheat. Alright, the metal can, the TO92 body, we can do the same. Now the metal can is more convenient than the black body because it's got a little index on the one side. And usually the leg closest to the index is the emitter. The one in the middle is the base, and the one on the side, opposite of the tag, is the collector. So we can prove it. This one is a BC107, a very standard transistor as well. And if I plug it in with the idea that the tag goes by the emitter, the middle leg goes by the base, and the collector goes by the collector, then with a little bit of mechanical ingenuity and a bit of patience, you will notice this transistor has a gain of 317. So the HFE or the beta DC is 317, 316. If I warm it up with my finger, it takes slightly longer than the black one, but still the beta increase because of increase of temperature, and it will decrease. If I blow it slightly, there it comes down. The metal can takes a bit longer to cool down, but the principle is exactly the same. So the junction, the gain, the input base current, the output collector current, everything is tied into one relation, and that purpose is to amplify with a small current into a big current. And that, ladies and gentlemen, is how I measure beta DC and how I determine the leg arrangement of any transistor. Thank you.